Good evening, dear students. Yes. So in the last class, we have started. With aldehyde, ketones, and carboxylic acid, right? So we have solved some 9 questions. Okay. So today we are going to continue with the same. So, so let us start. Okay. So this is the 10th question. Okay. We are seeing the correct sequence of steps involved in the mechanism of Carinzaro reaction is. The correct sequence of steps involved in the mechanism of Carinzaro reaction is. So here you need to know the Carinzaro reaction, okay, how the Carinzaro reaction works, what all the steps are involved. So here are the 4 options: A, nucleophilic attack, then transfer of H minus, okay, and transfer of H plus ion. Then B option, transfer of H minus, uh, then transfer of H plus and nucleophilic attack. C option, transfer of H plus, nucleophilic attack, and then transfer of H minus. Then D option, electrophilic attack by OH minus, then transfer of H plus and transfer of H minus. So here are 4 different options. Okay, you need to tell in which among the following it will, in which sequence it will undergo. So this is a 10th question, okay, which we are seeing here. So how does the Carinzaro reactions, where it is used? Carinzaro name reaction is a very important name reaction. Where we use Carinzaro name reaction? For the Yes, already we have discussed these all things in our 8th classes. I want the answers. Carinzaro reactions, where we use Carinzaro reaction? Okay, Sri Varuni and Lubna has answered it as A. My question is, where do we use Carinzaro reaction? Carinzaro reactions are what type of reactions? What we prepare from Carinzaro reaction? So Carinzaro reaction, what we do? We take 2 aldehydes, right? 2 aldehydes are taken in Carinzaro reaction, and what will happen? These molecules, okay, they will undergo disproportionation and they will produce what products are formed. One will be a carboxylic acid, another will be a alcohol, right? So this is our Carinzaro reaction, right? So here what are involved? Aldehydes are involved, right? Aldehydes are involved. Fine. So what are the sequence? So if I write the reaction, okay, how it involves. So this is our uh, okay, aldehyde, formaldehyde. So this is our formaldehyde. So I'm going to attack first by a OH minus ion. So how this attack takes place? So this will attack the carbonyl carbon. This will polarize the bond. Okay. Then, so this is a nucleophilic attack takes place. Okay, OH minus. So first nucleophilic attack takes place. Okay. Then, so this is a fast reaction. So what forms here? So here HCO minus, okay, and this is OH and H, right? So like this, and then, okay, then again what we are going to do? We are going to attack with one more formaldehyde. Okay, what we said, we are going to take 2 formaldehyde. So first formaldehyde we took here, okay, and second after forming this product. Now again what way is going to happen? So this here, it will attack this carbonyl carbon. Again it will polarize the bond. Okay, so here, so like this the attack takes place, right? Like this the attack takes place. Then how the, what is the product? So here what is hydride ion is getting transferred, right? So H minus ion is getting transferred. So this is the second step where hydride ion is getting transferred. Okay, H minus ion. So what I am going to get? H C double bond O and OH, right? OH. and plus what we are going to get H. So this is OH minus, and here what we are going to get HC, H and O minus. Okay, so this is this product here, and this is this further step. Okay, then what we are going to get now here, what is happening, your if I transfer this H minus, okay, if this transfer of H minus takes place, what it will result into HC, then double bond O and O minus. Okay, if the hydride ion transfer takes place. Now here I want what? I want H plus, okay, because it is in its oxide form, right? O minus form. So if I add H, okay, if I add H plus proton transfer, if it is taking place, so I'm going to get a alcohol. So one, I'm going to get a carboxylic acid. So this is a carboxylic acid, and this is your alcohol is the product. So what are the steps involved? First is a nucleophilic attack taking place. Then hydride ion is getting transferred, and then the what is happening from here, your hydride ion is getting shifted. Okay, here that is the transfer of proton is taking place. So yes, option number A is the correct answer. Option number A is the yes. Yuvraj has answered, Lubna has answered, and Sri Varuni has answered. Very good. Okay, Amulya has answered. Fine. Okay, so these are the steps. So I have told you stepwise how the reaction takes place. Let us go for the next one. Benzaldehyde and acetone can be best distinguished using. Benzaldehyde and acetone can be best distinguished using A. Fehling solution, B. Sodium hydroxide solution, C. 2,4-DMP, and D. Tolerance reagent. How does benzaldehyde and acetone can be distinguished? Yes, benzaldehyde. So this is your benzaldehyde. Okay. So this is your benzaldehyde. And acetone is what? CH3, C double bond O and CH3. So this is your acetone. Okay. So acetone and your benzaldehyde. So what I'm going to do, so here benzaldehyde and acetone. So how you are going to distinguish? So these are the four options. Fehling solution, sodium hydroxide solution, C by using 2,4-DMP test, and D by using the tolerance test. So how you are going to distinguish? And one is a aldehyde, okay, one is a aromatic aldehyde, another is what? Another is a ketone. Okay, one is a aldehyde, another is a ketone. How will you distinguish? Right one, sir. Okay. So I've got the answers. Many answers I've got. So Lubna has answered it as D. Yuvraj has answered it as D. Baby has answered it as D. Amulya Sri Varuni has answered as D. Srujana has answered as B. Okay. So benzaldehyde and acetone. Okay. So when we see benzaldehyde, okay. So benzaldehyde is what? It is a reducing agent. Okay. It comes under reducing agent. So if I treat this, so the best test is by using the tolerance test, because benzyl, we know that tolerance test, okay, tolerance test means ketones, okay, ketones does not give tolerance test, right? So one is aldehyde, another is a ketone. So the best test to distinguish between aldehyde and a ketone is the tolerance test. So as we know, benzaldehyde is a weak reducing agent. So what it does, it reduces the silver mirror, right? So it is a silver nitrate solution is there, and it forms what? Silver mirror. Okay, so with benzaldehyde, it forms a silver mirror test, but with the your acetone, it does not give the test. Okay, it does not give the silver mirror formation. So yes, option number D is the correct answer. So remember that if there is a aldehyde and a ketone, So how you can distinguish is the by using tolerance reagent, because because ketones does not answer the tolerance test. Okay, fine. Let us go for the next one. The reagent with which both acetaldehyde and acetone react is the reagent with which both acetaldehyde and acetone react is. So which is the reagent with which both the acetaldehyde as well as your acetone will react? Okay. So there are four options. Uh, Felling solution, B iodine with NaOH, C tolerance reagent, and D carbonic acid. The reagent with which both acetaldehyde and acetone react is. So let me write the acetaldehyde. Okay, so acetaldehyde will be what? So this is your acetaldehyde and acetone is this. This is the, okay, so this is our acetone. Now here in both the case, what you can see, what is a group, a common group present? It is a acetal group is present, right? In both the cases, what is present? There is a acetal group, and this acetal group, okay, if it reacts with the iodine, okay, in NaOH, it will give you a LOPPT. Okay, it gives you a LOPPT, that is iodoform test. Okay, that is a iodoform is form. So it gives you the iodoform test. So the both acetaldehyde and acetone, they react with iodine in NaOH because they answer the iodoform test. Why? Because in both the this what is present, acetal group is present. Okay, acetal group is present. Okay, so yes, Lubna, Amulya have answered. Sanjeevni, Sujana, Baby have answered. Okay, very good. Okay, so yes, B is the correct answer. So iodine with NaOH. So it will give you a LOPPT that confirms that it is a iodoform test. Okay, because of presence of the acetal group. Next one, predict the product in the following series of reaction. So you have to predict the product in the following series of reaction. Okay. So the reaction is acetic acid, okay, CH3, COOH, acetic acid. It reacts with what? It reacts with your, just a second. Let us see next one. There is some. Okay. Lower members of aliphatic carboxylic acids are soluble in water. This is due to lower lower members of aliphatic carboxylic acid are soluble in water. This is due to lower members of aliphatic acid are soluble in water. This is due to A. Formation of hydrogen bonds with water. B. London forces. C. Water is non-electrolyte. D. Van der Waals interaction with water molecules. Why the lower members of aliphatic carboxylic acids they are soluble in water? What is the reason? What is the reason? What is the reason? Carboxylic acid, C double bond OH. Okay, and why they are soluble in water? Okay, so between the water and carboxylic acid, What type of bonding is formed? It is a hydrogen bonding is formed. So because of hydrogen bonding, so carboxylic acid forms what? Hydrogen bonding with water. Okay. So option number A is the correct answer. Okay. Let us go for the previous question. Okay. Let me see the. Okay. So it is, the question is, so the reaction is like this: acetic acid, okay, acetic acid reacting with PCl5, okay, giving you A. Then further reacting with C6H6, okay, your benzene in the presence of anhydrous AlCl3 to give you B. Further reacting with your methyl magnesium bromide to give you C. Okay, so you have to what you have to find the product C. Find the product C in the following. So these are the options: CH3, C double bond O, CH2, CH3. Okay. Then CH3, CH, OH, C6H5, C, CH3, CH, OH, C2H5, and D, CH3 twice, C, OH, C6H5. Yes. What is the answer? Lubna has answered it as D. Srujana has answered it as B. Sri Vanuni has answered it as A. Okay. So let us see the steps. Okay, let us see the steps involved here. So acetic acid, when it reacts with PCl5, okay, that is phosphorus pentachloride. Okay, what will happen? What will happen? Your OH, okay, so this is what? CH3, C double bond O, OH. So your OH group is replaced by the Cl. So what it forms? It forms CH3, C double bond O, Cl. Okay, so this is your so this is a acetyl chloride. Okay, option number this is your A. So this is your A. Further, it is reacting with what? It is reacting with benzene in the presence of anhydrous AlCl3. Okay, in the presence of anhydrous AlCl3. So what will happen? Your acetyl group, okay, your Cl minus. Okay, now your Cl minus will be replaced by the benzene ring. So you are going to get what? You are going to get this CH3. Okay, benzene CO CH3. Okay, now here further I'm going to treat it with what? So this is your product B. This is your product B. Now further what I'm going to get? This is your acetyl benzene. Okay, so this is your acetyl benzene. So further I'm going to treat it with what? Methyl magnesium bromide. That is your Grignard reagent. What I'm going to get? So at your carbonyl carbon the attack will take place, and what I'm going to get? This is your benzene, then C, OH, CH3 and CH3. So this is your product C. So it is C6H6, C, OH, CH3, CH3. So option number D. Option number D is the answer. Option number D is the answer. Yes, Sri Varuni has answered. Very good. Lubna has answered. Yes, D is the correct answer. Okay. Okay. Understood? Okay. So this is the way you're going to solve. Fine. Okay. Let us go for the next one. In the following sequence of reaction. So this is the following sequence of reaction. So methyl bromide, okay, CH3Br in the presence of potassium cyanide, okay, gives you A. This further undergoes acid hydrolysis, okay, to give you B. Further, in the presence of lithium aluminum hydride, gives you C. Okay, so you have to find the product C. What is the end product C? A methane, B ethyl alcohol, C acetone, and D acetaldehyde. Follow the steps. First is what? First is your methyl bromide reacting with KCN. Okay, methyl bromide reacting with KCN. So your Br will be replaced by what? Your Br will be replaced by Cn. Okay. So it will be CH3Cn. CH3Cn. Further, it will undergo acid hydrolysis. Okay, it will undergo acid hydrolysis. So what will happen? Your cyanide group, okay, it will undergo oxidation to carboxylic group. Okay, you will going to get acetic acid. It is undergoing acid hydrolysis. So your cyanide group will form acetic acid. That is your carboxylic acid. Okay, is introduced COOH. Okay, it is undergoing oxidation. Further, so this is your B. This is your B. Now further, what is lithium aluminum hydride? Lithium aluminum hydride is a good reducing agent. Okay. So what will happen? There will be removal of oxygen and addition of hydrogen. Right. So what will happen? So CH3, CH2OH. Okay. So what I am going to get? I am going to get a alcohol. So I got what? I got alcohol. That is option number, that is your product number C. Okay, so it is your ethyl alcohol. So what is the answer? Option number C. Okay, option number C is the answer. Understood? So first step, we have taken methyl bromide reacted with KCN. Okay, so your Br group is replaced by Cn. Further, it is undergoing oxidation. Okay, so there will be introduction of carboxylic group CH3COOH. This further reacting with lithium aluminum hydride, which is a strong reducing agent, it forms ethyl alcohol. Okay, alcohol is formed. So it is undergoing reduction. Okay. So there will be removal of oxygen and addition of hydrogen. So yes, option number B is the answer. Okay. Let us go for the next one. Carinzaro's reaction is an example of auto-oxidation. A. It is a typical reaction of aliphatic aldehydes. B. It is a reaction answered by only aldehydes containing alpha hydrogen. C. It is reaction answered by only aromatic aldehydes. D. It is a reaction answered by all aldehydes. Yes. Carinzaro reaction is what type of reaction? Carinzaro reaction is what type of reaction? So, Carinzaro reaction, okay. Carinzaro reaction should not contain any alpha hydrogen. Okay, so the aldehydes which do not contain, okay, aldehydes do not contain alpha hydrogens, okay. So they undergo the Carinzaro reaction. But here there is no such option, so all the options are wrong. Okay, so Carinzaro reaction is example for what? For the aldehyde. Okay, so it is the best example for the aldehydes which do not contain any alpha hydrogen. So we had taken with your formaldehyde, right? We had shown Carinzaro reaction with formaldehyde, so there is no alpha hydrogen involved. So the aldehydes which do not have alpha hydrogen will undergo what? They will undergo the Carinzaro reaction. Is it clear? Okay. They should not contain. Okay. Your option they have given what? Aldehydes containing alpha hydrogen. No. Aldehyde should not contain alpha hydrogen. So the hydrogens, this aldehydes which do not contain alpha hydrogen, they will undergo or they will show the Carinzaro's reaction. Okay. Which of the following compounds undergo haloform reaction? Haloform reaction. Which of the following compounds undergo haloform reaction? First one is your ketone, second one is your formaldehyde, third one is your alkyl bromide. Okay, that is ethyl bromide. Then fourth one is your ether. Baby has answered it as C. Others, which of the following will show haloform test? Compounds will show haloform test. So which are the so it should, so the haloform test, okay, that is your iodoform. Just now we had seen iodoform is best answered by the compounds having the acetyl group, or it should have CH3, CH, OH. Okay, such groups. So in that compound, such groups should be present. So they will only show the haloform test. Okay. So now here, which compound has this acetyl or CH3CHOH group? It is A, acetone. So acetone will show your haloform test. Yes, option number A is the correct answer. So Sri Varuni has answered it as A. Very good. So haloform tests are best answered by whom? They are best answered by the compounds containing acetyl group, that is CH3CO group or CH3CHOH group. Okay, fine. Let us go for the next one. The carbonyl compounds, a compound that does not undergo aldol condensation is, the carbonyl compound which does not undergo aldol condensation is A, dichloroacetaldehyde, B, trichloroacetaldehyde, C, acetaldehyde, and D, acetone. The carbonyl compound that does not undergo aldol condensation is. Yes. So for aldol condensation, there should be a alpha hydrogen, right? There should be a alpha hydrogen. So for the compound to be undergoing aldol condensation, they should have alpha hydrogen. Now you have to see the carbon that does not undergo aldol condensation means it should not have the alpha hydrogen. Okay, so there should be absence of the alpha hydrogen. If there is absence of alpha hydrogen, that means what is present? So dichloroacetaldehyde. Dichloroacetaldehyde is what? So this is your aldehyde. So dichloro means 2. So this is, so there is a alpha hydrogen. One hydrogen is present here in the first. So this will undergo aldol condensation. Then acetaldehyde CH3 C double bond O H. Okay. So here also there is a alpha hydrogen. Right. Here is also a alpha hydrogen. Then next is what? Acetone. So here is also your alpha hydrogen present. Right. So alpha hydrogen is present. So here also it will undergo. Now trichloroacetic acid, let us see. Trichloro means Cl, Cl and CHO. So here all the three are chlorine. So there is no any hydrogen. So it is trichloroacetaldehyde. Okay, trichloroacetaldehyde. So option number B. Option number B is the answer. Understood. What is alpha hydrogen? Next to carbonyl carbon. Okay, whichever the carbon is present, it should have a hydrogen. That means it is a alpha hydrogen. So next to carbonyl carbon, for that carbon, there should be a hydrogen. So this is alpha hydrogen. For aldol condensation to carry out this is what it the carbonyl carbon, beside the carbonyl carbon, the alpha hydrogen, alpha carbon should have a hydrogen. Okay, there should be presence of hydrogen. So there is a rule for undergoing aldol condensation. So when we see the options, so first C and D, A, C and D, these compounds, there is a presence of alpha hydrogen. So they will undergo aldol condensation. The question asked is which will not undergo. So it is option number B, trichloroacetaldehydes, because all the hydrogens are replaced by what? They are replaced by the Cl. Right, so it is a trichloroacetaldehyde. So option number B is the answer. Okay, let us solve some more. Okay. 35th question. Reduction of ketones cannot be carried out with which of the following reagent? Reductions of ketones cannot be carried out with which of the following reagent? A. Hydrogen in presence of palladium in barium sulfate and quinolone. B. Sodium borohydride or lithium aluminum hydride. Then C. Zinc amalgam and concentrated HCl. And D. Hydrazine and potassium hydroxide in ethylene glycol. Yes, how we are going to answer this? Reduction of ketones cannot be carried out with which of the following reagents? Ketones. Okay, so reduction of ketones, how you cannot do? You cannot reduce ketones, okay, by using hydrogen. So option number A. So hydrogen. So reduction of ketones, you cannot do reduction of ketones by using the this hydrogen. Okay, hydrogen in palladium. Okay, in the presence of barium sulfate and quinoline. Fine. So option number A. Option number A is the answer. So by using this, so with other reagent, with lithium aluminum hydride. Okay, lithium aluminum hydride is a strong reducing agent. So by using sodium borohydride or lithium aluminum hydride, you can do reduction by using zinc amalgam and concentrated HCl. Also, you can do a reduction by using hydrazine, NH2. Okay, hydrazine and KOH in ethylene glycol. You can do reduction, but by using hydrogen. Okay, so that is a hydrogenation reaction, simplest reaction. So but ketones cannot be reduced. Okay, hydrogen in the presence of palladium is a reducing agent, but your ketones cannot be reduced with this reagent. Okay, fine. Okay, next question. The appropriate reagent for the following transformation is, which is the appropriate? So here what is happening? So you can see rest of the molecule is same. Rest of the molecule is same. Only your C double bond O is reduced to CH2. Which is this name reaction? Which is this name reaction where carbonyl compound is reduced? Okay, they are reduced to a your this what? They are reduced to CH2 group. Yes, which is this name reaction where your carbonyl compound is reduced to your CH2 group, that is hydrocarbon. Where it is done? So this it will undergo in the presence of what? It will undergo in the presence of, by using zinc amalgam in the presence of HCl also, and using hydrazine. Okay, in the presence of KOH also you can reduce these two. Okay, so both these reagents can be used, but the best reagent for the transformation is hydrazine, because if we use this zinc amalgam in the presence of HCl, so what will happen? There is a Cl minus ion, right? So this Cl minus ion, okay, what will happen? The OH here, what will happen? Your carbonyl carbon group will be it will become OH. So what will happen? In case if you use this reagent, your OH will be replaced by Cl. So there are chances in both with both the reagents you can do the conversion of carbonyl to hydrocarbons, but the best reagent is option number 2, that is hydrazine in the presence of OH minus or ethylene glycol. Okay, so these are the second one. Okay, so by using this reagent you can do the uh, conversion from carbonyl carbon to your hydrocarbon. So option number B is the answer. Okay. Next question. In the following reaction, the compound Z is. So which is the compound Z in the following reaction? So your toluene is there. Okay. You are reacting with CrO2, Cl2. Okay. Then you are going to get X. Okay. So this is taking place in the presence of carbon disulfide and X is formed. So further it will go acid hydrolysis to give you Z. Okay. So what is the option? This. So what is the compound Z they have asked? What is the compound Z? Yes. A. Acetaldehyde. Options are wrong. Okay. There is some mistake in questions in the compound. Okay. Yes. So which are the so in the following, what is the compound Z they have asked? The compound Z is, so don't look at this. Okay. So don't look at this. Yes, answer this. So in the following reaction, the compound Z is A. Benzoic acid, B. Benzaldehyde, C. Acetophenone, and D. Benzene. And D. Benzene. So toluene, okay, toluene. Then I'm going to do chromylation, okay, by using chromyl chloride. So what I'm going to get here? What I'm going to get by using chromyl chloride in the presence of carbon disulfide? What I'm going to get? What will be the product? Yes, what will be the product formed here? It will form the chromium complex. Okay, it will form what? Chromium complex, that is CH. Okay, OCrCl2OH and OCrCl2OH. So a chromium complex is formed. This chromium complex further what it will do? It will form, it will undergo hydrolysis, acid hydrolysis. Okay, and your CH3 group, your methyl group is converted into a aldehyde group. So the compound is benzaldehyde. Option number B. Please note this. Please note this. Okay, so it is going to form a chromium complex. So this chromium complex is brown color. Okay, it forms a brown chromium complex. Okay, so what is the what you are going to do? You have a toluene. You have a toluene. You are reacting with chromyl chloride. Okay, in the presence of carbon disulfide. So what is happening? Oxidation taking place. So what is happening here? CH. Okay, both the hydrogens are replaced by these groups. Okay, your chromyl groups. It is forming a chromium complex. Further, when it undergoes acid hydrolysis, it forms what? It forms a aldehyde. So you get a benzaldehyde as a product. So option number B is the answer. Okay, is it clear up to here? Yes. Okay, Sri Varuni, Lubna have answered it as B. Very good. Okay, going further, moving further. Okay, which is the most suitable reagent for the following conversion? So, which is the most suitable reagent for the following conversion? So, CH3, CH double bond CH, CH2, C double bond O, CH3. So, here only your CH3 is replaced by OH. So, which is the best reagent for this conversion? Yes. So, these are the options. A. Tollens reagent. B. I2 in the presence of NaOH. And C. Benzoyl peroxide. D. SN and NaOH solution. Tin and NaOH solution. Yes, which is the best reagent? So for this conversion, that is CH3, CH double bond, CH, CH2, C double bond O, CH3. Okay, 2 what? CH3, CH double bond, CH, CH2, C double bond O, OH. So for this conversion, okay, if we use I2 haloform test, okay, I2 in the presence of NaOH, okay, I'm going to get what? I'm going to get a haloform, iodoform. Okay, iodoform test is answered. So it is option number B. Option number B. So for this conversion, okay, we are going to use I2 in the presence of NaOH. So option number B is the answer. Yes. Okay, Sanjeevni and Lubna have answered. It is option number B. Okay, so how are the steps? So if I react it with I2 in the presence of NaOH, okay, so what will happen? First step, so you are going to get a iodo form. Okay, CHI3 plus CH. So here CHI3. So here what will happen? Okay, you are going to get CHI3. Then your CH double bond CH CH2 C double bond O Na plus, right? So this is the iodoform test plus 3NaI. So this is the byproduct plus 3H2O. Okay, further what will happen after doing the okay, it will take up a proton, and here your CH3 CH double bond CH CH2 C double bond OH. Okay, so this is the test. Understood? Okay, so it will answer what? It will answer a iodoform test. Fine. Okay, let me explain you again. Here, the reaction is CH3, CH double bond, CH, CH2, C double bond O, CH3. Okay, now if I react it with the iodine in the presence of NaOH. Okay, this is the iodoform test. So what is happening? Your this bond is broken. Okay, and it is going to react with this iodine, and I'm going to get what? CHI3. Okay, so iodoform is formed. Now here what will attack? Here your OH will attack. Okay, here your OH will attack. So ONA will attack. So what I'm going to get? So here at your NaOH. Okay, so here ONA. So what I'm going to get? Plus CH3 CH double bond CH. Okay, then CH2 C double bond ONA. Right? ONA. So O minus Na plus. Plus what all is left? 3Na. Okay, so this will be 3I2. So I have to balance it. So this is 3I2 and 4NaOH. So I'm going to get 3NaI plus 3H2O. Okay, now further what will happen? This will take one proton, and I'm going to get CH3, CH double bond CH, CH2, C double bond OH. Understood? So this is the reaction. Iodoform test. Okay, this is the iodoform test. Is it clear now? Is it clear? Okay, fine. Okay. So these are similar questions which we have solved. Okay. Okay. Ethanoic acid does not undergo Hell-Wohlhardt-Zelensky reaction, but methanoic acid does not. Okay, ethanoic acid undergoes HVZ reaction, but methanoic acid does not. What is the reason? A, absence of alpha hydrogen atom in ethanoic acid. B, higher acidic strength of ethanoic acid than methanoic acid. C, presence of alpha hydrogen atom in methanoic acid. D, presence of alpha hydrogen atom in ethanoic acid. Yes. Why? Your what is Hell-Wohlhardt-Zelensky reaction? Hell-Wohlhardt-Zelensky reaction is used for the this your carboxylic acids. Okay, so carboxylic acid. So if I take a acetic acid, okay, and what is the reagents used? It is bromine in the presence of red phosphorus. Okay, and it will further undergo hydrolysis. Okay, so what I am going to get? So at your alpha, one of the alpha hydrogen will be replaced by Br. Okay, so this is your Hell-Volhard-Zelinsky reaction. Now here ethanoic acid undergoes. So this is your ethanoic acid, right? Ethanoic acid undergoes Hell-Volhard-Zelinsky reaction with methanoic acid does not undergo. What is the reason why methanoic acid does not undergo? Yes, because there is no alpha hydrogen. So what is the reason for any this? Okay, for any in your ethanoic acid, what is present? Your alpha hydrogen is present, but in methanoic acid, there is no alpha hydrogen. So alpha hydrogen is necessary for the Hell-Volhard reaction. Okay, so so you can see here when I write the methanoic acid, there is no alpha hydrogen, right? There is no carbon to which the hydrogen is attached. So here you can see there is a alpha hydrogen next to the carbonyl carbon, right? So option number D is the answer. Option number D is the answer. Okay, fine. So these are some of the questions based on carboxylic acid. Let us see. The general name of the compound formed by the reaction between aldehyde and alcohol is. So when aldehyde reacts with alcohol, what is the compound form? A. Glycol, B. Acetate, C. Ester, and D. Acetal. Yes, when aldehyde reacts with your alcohol, what compound is formed? Yes, what compound is formed? Anybody? Yes. So it will form RCH, okay, OR and OH. So further reacting with alcohol gives you RCH, OR and OR. Okay. So I'm going to get what? I'm going to get a acetal. Okay, I'm going to get a acetal. So remember that whenever aldehyde and alcohol reacts, what is formed? Acetals are formed. Okay, what are formed? Acetals are formed. Okay, let us go for the next one. Okay, the test to differentiate between pentane 2-on and pentane 3-on is. So which is the test for pentane is CH3, C. Okay, pentane 2-on. So this is pentane 2-on and this is pentane 3-on. Okay. So between these, how which test we can use to distinguish A. Felling's test, B. Iodoform test, C. Bayer's test, and D. Benedict's test. Yes, we have seen this. So which group is present? So we can use iodoform test, right? So if I use iodoform test, your acetyl group is there. So it will give positive test, right? Iodoform test will give positive test for the presence of acetyl group, right? And for this, it won't give. So we can differentiate. So iodoform test, it is used for ketones, okay? Where your CH3 C double bond O group is present, right? So acetyl groups, yes. Option number B. Very good. Yes. Let us go. Next one. The IUPAC name for the following compound is. What is the IUPAC name for the following compound? What is the IUPAC name? Start numbering. Okay. Then so your carbonyl group is taken as a substituent. So it is When you take as a your substituent, you have to name it as, that is your ketone. It is named as what? Oxo, right? So 4-oxo. How many carbons are there? Pentane, okay? And it is a carboxylic group is present, so it is pentanoic acid. 4-oxo pentanoic acid. So option number B. Okay, option number B. So your keto group, okay, it is acting as a substituent between the carboxylic acid and ketone. Okay, carboxylic acid will have the priority to form the parent chain. Okay, so this is the name 4-oxopentanoic acid. Is it clear up to here? Okay, so these were some of the questions based on aldehyde, ketones, and carboxylic acids. Any doubts? Any doubts? So this completes our chapter aldehyde, ketones, and carboxylic acid. So I've tried to solve. So I've tried to solve maximum number of questions on this chapter. Okay. Yes. Anybody wants to ask anything? Any doubts you have? Yes. No doubts. Okay. So I'll end the session here. Okay. So we'll meet in the next week. Thank you.